Yeah, all right. That looks good. Okay, so we're gonna make sure everything's set up correctly. All four of these circuits are hooked up. We got two circuits per coil, one on 20 gauge, one on 30 gauge. Both 30 gauges are over here, both 20 gauges are over here. All right, so what we're gonna do, I should probably get my notebook. I'm gonna go grab that real fast. So we're gonna call it. I'm gonna call this the 180-degree pulse motor. And then I'll make just an outline of how I want the experiment to go. So, one, we'll do, hi,
I love you.
love you too.
What are you doing?
I'm writing down the experiments.
Okay. What are you gonna do?
I'm going to write them down.
I'll be right back.
All right. So the first experiment is going to be okay, all four strands connected in parallel.
I'm back.
Hey,
I'm back.
good. Welcome back. So this is all four strands connected in parallel. All four transistors are hooked up. Let's give it a shot and see what we got. Well, let's explain it a little bit further. No, leave that there, Caleb.
Okay.
Love you, buddy.
That's like glue on here.
That's right. Okay, so these are bifilar coils. They have cores in them that are apparently too large. So I'm just going to take them out real quick. This will be new. We're going to do without cores, 1A. With
Easy.
out core slash air core. This is why I don't write stuff down, because it's like abysmal. It's hard for me to read it.
Press this.
Okay, cool. This is an external trigger coil, which I currently have every strand hooked up to. So they're all going to hit when this coil fires. Okay? I'm not even sure if they're going to hit now. We'll see. We're going to start off at 4 or 5 volts. Well, we're trying to see max RPM for the setup. So this is all 4 strands connected parallel without a core. Here we go, 5 volts in. Oh, that looks good. We're gonna juice it up to 9 volts. We're going to be measuring a couple things for each experiment. 10 volts. We turn on the multimeter here. Maybe I can move this into the shot. You might be able to see it, kind of. Alright, so we got our little wave. This is off the big blue coil down there. Now we're going to see how much AC volts we're generating. 40 at the moment at 9 volts or 10 volts in. We're doing 40 with all 4 strands. We're going to up it. We're going to make our max around, we're going to make it around 1 amp, 1.2 amps. We're at 0.7 right now. This is without a core. And we're going to go straight up to 15. Well, you can hear that. Wow. Okay, so what we want our max input to be right now, it's at 15 and about 1.1 amps. We're going to make that steady, so it's at 780 RPMs, 783. We're going to call it 780. But we can put more in. We can put a little bit more in. We're going to do that. Our lights are lighting up on the SG. They're starting to fire off. They're firing off over here too. 16. 17. 1.3 amps. 17.5 volts. And get another reading. Alright, now the cool part about this setup, we're at 860, right? Now watch this. $947, $950. And that's just the start. You can move it one more time. Yeah, we're starting to get vibration in the shaft. 982 RPMs. 984. One more time. Can we adjust it to go above 1,000? Let's see. 1002. Heck yeah, we're gonna cut it back. Wow, that's awesome. 1002. It was at 1.7 amps, so I had to cut it down. I mean, it's a 1 amp system, so um, we're gonna put 1005 for the no core version. Now, do I even want to put these in there, considering they're like twice as big as they need to be? Yeah, we're gonna do it. One B with core iron 40%. And then they up it. They up the value of the iron content to 45%, and I got myself some of that coming in the mail. Let me turn around and take a gander at what's going on here. Hey, what's up, everybody? It's Papa Bale. Welcome to Pulse Motor Mayhem. Right now, I'm just changing up a variable in the experiment. There's going to be lots of those, so I can't get it from this side. So the first answer of max RPM was 1005 RPMs we just did without cores. All right, we got it. Sweet. All right, now we're going to do it with core. And 17.5 volts in was our max, but we're going to start off at 4 or 5. Work our way up. Yeah, about 5.5. Now that's just for the burst here. This is what's triggering the bass right here. We'll put that back to, center it out at 90 degrees. That's where you started at, and then you move it, and then it's like, whoa. All right, so this is experiment 4 strands connected in parallel with a core. So that's 2 strands per coil, external trigger, and Big Blue is generating AC voltage. On the side, 10 volts in. $12 volts in. Generating 46 AC volts at the moment. 48. 50. We're now at 15 in. 1 amp. 1.2, 17.1. There we go. 1.2. Now we're going to adjust. Watch what happens here. If you don't hear that, I don't know how to get it so you can hear it. Alright, we're going to take the reading. It's at 1.4. Yeah, 1011, 1017, 1017. Awesome. Alright, and that's just the tip of the iceberg. So we're going above 1,000 RPMs with both of those. $17. Alright. Huh. Where did I put the cap to this thing? That's unfortunate. Got my screwdrivers in my pocket here. I thought I would have put it in there. Alright. Maybe it's in this pocket. Yeah. Oh, here it is. Cool. Found it. At least I didn't struggle with that for too long. Alright. Now, we're going to do something that I haven't tried yet. We're going to need my trusty screwdrivers. We're going to run just the 30 gauge strands now. I haven't tried that yet. I don't know what the effect is going to be. I can guess it's going to go slower and have a much less amp draw. I'll be able to turn it all the way up, I bet. And then we're going to flop it. We're going to flop it and we're going to do just the 20 gauge. And then we're going to do single input and we're going to run SG through all four of them. So we'll have the initial SG and plug into an SG, into an SG, and I know it's not supposed to go into itself, but I bet it'll run and increase, do what it's supposed to do. I bet that's what will happen. Just because you shouldn't do it doesn't mean you can't do it. And I know that's wrong, but it's what I do, I guess. Like with the cores here, I use them. I guess I'm not supposed to be using them, but I use them. Alright, let's do it. We're doing just the 30. We'll start off at 9 volts. Oh, wait. We need to take the cores out again. Oh no, let's do the with core first this time. Alright, we'll do that first this time. I was just making sure it was going to work. I probably shouldn't have done that. Spoiled it. Spoiled whether or not it was going to work. Okay, so I'll mark what strands are on number 1 on the side here, and I'll start to put in like 2 30 gauge Experiment number 2, 230 gauge. All north. Mags on the rotor. Four magnets. Okay. So I guess we'll start off at 9 like we did. And we'll put width, core. 40% to a max RPM. We'll level this off again. Alright, it's now at 24 volts in, 0.2 amps. This is max. This is as max as I can get it. Alright, that light's pretty bright. Let's move this. $212. I don't think there's really a point in doing another one. Yeah, that's not any good. Surprised it got any action when you did all four. We'll see what it adds up to. So we're gonna give it a generous 250 RPMs. And I prejudiced the experiment by I'm gonna put mark it down. 24.9 volts and 0.2 amps in. Alright, 2B. Without core or air core. Let's get it going. $17.5. We're gonna go right to it. Yeah, it's 0.1, 0.2 amps in. $178. Let's square this off. $100. Now we're gonna let it speed up a little bit. I hope that's what it's doing. Yep, 200. Gonna increase the torque a little bit by moving this. About 210. Doesn't want to go much faster than that right now. Okay, 30 gauge wires get about 210. Of course, it wasn't exactly 210. There was a couple 208s, 211. We're gonna give it 210. Okay, now experiment number 3. I'm going to swap out the 30s for the 20s. 2, 20. Same rotor. And we'll start three A without core, air core. Whew. I have to take this shirt off in a second. Alright, so let me swap those. Gonna get electrocuted. Some sweat dripping off my face. It's gonna be in perfect resonance and sync with whatever I'm working with, and it's just gonna shock me to death. Whew. Alright, here we go. I might have to approach this from a different angle. There's one. There's two. Oh man, that sucks. Okay, got it. Alright, and then I gotta undo these two. We already know what the both of them together do, which is pretty impressive. It's like 1,020 RPMs or so. Alright, so now we're going to try the 20s, and this should be more impressive than the 30s. Hell yeah. Woo! $12 volts. We're only at 0.5 amps though. And so what we've done is switched from these two to these two. So now these two are active. So there's a lot of stuff going on when I switch these things. Seventeen point 0.8 amps. $796. 800. These are already way better numbers than I'm used to using the external trigger coil. So we are gonna start moving that around in just a second. 810. All right, let's do that. See if we can increase the rate of speed that we are increasing. Whew. And I can feel the difference. 908, 918, 927. Haha. 940. 967. 971. 0.1 amps. Or 1.1, my bad. 1.1 amps. That is such a smooth running thing. That's awesome. That's so well, like, there's barely any vibration up to 1,000, and it's big too. It's not small. If it was smaller, I would expect it to go faster. If it weighed less, same deal. Yo, what's up, Peter? My bad. I've been so into doing this that I haven't got a chance to turn around yet. Alright, so let me get that rotor that I'm actually discussing. This little devil right here can roll. It's fast. It's really fast. And that would be so cool. I wanted to try and hook it up with, this setup right here, but I don't know if it'll work because I think it's too small and the setup is not built for something this small, but we could find out. We could definitely find out, but there's still lots more I want to do. See, now you get that extra burst with the trigger coil on the outside. You can move it and you can increase your speed by changing the timing. I actually kind of prefer doing it this way, but there's still like 2 or 3 things I want to show you, and that's running it the way it's supposed to be run with the trigger strand in each of its respective coils, and then the trigger strand on opposite coils. because you get kind of the same benefit of running with an external coil when you run in opposite coils, because it is kind of the same thing, but you get electrification because it's inside of a drive coil, so it's not the same, it's just kind of the same. I don't think you get a chirp when you do it opposite. So this trigger will go and work for this coil or this circuit, and this trigger will work for this one. Neither one of those is as good as what you've just seen. But it has its own pros. I'm just talking about RPMs. I'm not talking about electricity generation or anything like that. I'm just talking about RPMs because that's what we're looking at. 970. Okay, now do we want to do with the core? We want to see if we can get it way above 1,000 with the core in there. All right. Yeah, I can. Let's see here. So I got some more infused ferromagnetic iron PLA coming. I'm totally out of it. After I made the former for my U-shaped coil. Okay, so yeah, let's get this going real quick. Alright, we're at 17.7.9. Between 0.9 and 1 amp. Alright, here we go. We gotta adjust the coil still, but it's at about 800 right now. Wow, that is such a good breeze, man. I'm loving this fan. 985. Try a little bit more adjustment here. Yep, that was it. 1010. Woo! Heck yeah. So cores do help. And in every way. Like they complete the coil. Even if they are bigger than the coil, they still help. So, I mean, there you go. Proof is in the pudding. With core. So this is just a raw data gathering thing, and I'll make it into something more presentable. All right, so that's setup number 3. So now we're going to do setup number 4. I think I need to turn the fan on for sure. Maybe get off this shirt. Gotta do that. All right. Okay. So I'm unhooking the external trigger coil and I'm hooking up this trigger coil right here. But I'm going to leave everything else connected the way it was, and it should. Well, yeah, let's give it a whirl. Let's see what happens here. So this trigger is now triggering for all 3 of the other strands. I don't know how to write that down, really. Huh. See if that'll even work. Let's get this bad boy out of here. confused. Alright, so this is a pulse motor, 180 degrees. There's 4 strands in play here. 2 30s and 2 20s. We got power going into the 2 20s and they're hooked up to 2 SG circuits. Now, it's not an SG machine. I'm just inspired by the circuits. So, they're kind of like SGs, but they're not hooked up the same way as an SG machine. It's just a circuit. So nobody gets confused. One of the 30 gauge strands, this one, is now going to trigger for all 3 of the other strands. Let's see how it goes. Wait a minute. I need to get my screwdriver out real fast. So it's only going to trigger the 2 20s. I want to get that 30 gauge in there real quick. I don't know if I'm going to be able to get it like this. Oh yeah, I got it. Alright, now let's do it. So put both of these and one of these will be triggered. Oh, we got light. We got light because we're now using an internal trigger coil. And you get that magnetic induction happening in there. The two strands working together. And then this is the result. Because all those other experiments, the light was off and it was ready to go. It just... There we go. There it goes. Woohoo! Alright, now these lights are starting to come on, and one of those lights is starting to come on. Alright, we're almost up to the mark here. Look at that light. And it's so bright. That's 100 watts, ladies and gentlemen. But it's an LED, so it's 100 watt of LED. Don't know if that means anything, but 965. 966. So I'm going to call it 960. 970. And that's with the one trigger for all 3. And I'm about to unhook that other strand and we're going to do one trigger for one coil. Corresponding coils, of course. And then we're going to flip them. We're going to do the flip thing. I love this light, man. It's bright. I guess I should try and write it down. trigger. Times 3 drive. Max give it one more reading here. Hopefully we're up to 1,000. Nope. 965. We're going to say 17.5 volts. 1, 1.1 amps. All right. That light was bright. Woo! Heck yeah. You see how bright that light got? All right. So Alright, so we're clipped in. Now I'm just trying to find one of these that is not hooked up. I know I have one. But that one is. That one is. We can use this one for now. I knew there was one just lying around somewhere. Sure that the right ones are going to the right thing, and this is it. This is standard trigger, corresponding coil, drive. This is that. Let's do it. it lights up. Now what I'm really curious about is if the next experiment the light still lights up, because we're going to switch the two triggers when the light lights up. The next experiment. Wow, dude. Woo! That's bright. That's a very low amp draw. Very low. $743. It is a low amp draw. I don't know why the amp draw is so low, but it is. .7 amps at 17.6 volts. That's low. Really low. But it's good. Look at how bright that light is. That's an SG output from this transistor right here. That's awesome. So I'm going to call it the standard hookup. Max RPMs. I got the voltage up here, so the max RPMs for said voltage is 750. Now, all we gotta do for this next one is switch this with that, and switch that with this. Boom. It's that simple. Now one trigger is triggering for the other transistors, so on and so forth. Here we go. And it works. It works at 9 volts. And it's quiet. The amps are a lot higher though. $975. Woo! That's a lot faster than the other way. And the lights up. Oh, that's so cool, man. So all I gotta do is swap them. You get extra RPMs when you swap them by about 300. And the light still lights up just as brilliant. That's awesome. So six. Standard reverse. Trigger. Oh, dang it. So looking at this, when you have your trigger coil inside the coil that you're firing, you get the bonus of having the light up through the SG, but it's 300 RPM slower than if you swapped it for a coil at 180 degrees. So if you have your trigger 180 degrees from the coil that's triggering, that's a good stationary position to have it in. Get about 300 plus RPMs from doing that. So all you need is two identical coils, bifilar, at 180 degrees. And then you got lots of options there. This is not replication of anything, so it's just, no, it's not an Adams motor, it's not a Bedini motor. The circuitry here is inspired by John Bedini's SSG. This is not an SSG machine. All I did was basically commandeer the circuitry, and that's it. The rest of it is all mine. That's what I do. It's like in Pretty Woman, how the guy, he like commandeers, buys all the companies and he sells them off piece by piece, right? And he keeps what he wants, kind of like what Elon does. You know, it's what happened. So yeah, I don't know. I got off track there. I'm really excited about this, though. So what I failed to do here is get any of these readings. Oh no, it's become disconnected. Wow. So I got like 400 microvolts standard running through my fingers at any given time. So this is no longer hooked up. So we can remove it for right now. Might get a different one out here, one of the more normal shape, I would say, like either like this or elongated a little bit longer. I'm going to turn around. Well, it spins, and it spins really fast. It's not the fastest thing in the world, but you know, it's a piece of plastic, so I think it goes pretty fast. Yeah, but this setup right here, if I had to leave my trigger coils inside the coil, this is how I do it. This is exactly what I would do. I'd do a 180 and I'd flip them. So, bam, because you get the light and you get the external quality. You get the extra speed boost. That you can't beat this. Just using what's already involved with it, you cannot beat this way right here. This is it. Even though it's not the most RPMs by like 20 or 30, you get the light. None of the other setups you got the light with. Hi,
Hi.
how you doing?
Good.
Good. You want to come in?
Sure.
All right. I was hoping my brother might come over when he was done playing disc golf.
All right.
Do you want to use the camera?
Sure.
Okay.
How do I get it off? Do I?
Hold on to it while you do that.
I can. Sorry.
You're twisting it.
I know.
Okay.
There we go.
There you go. Yeah.
I'm a little shaky.
Okay.
You want me to read out the chat again?
Oh, you don't have to read them all.
All right.
You can read some of them if you want. I got people helping me out while I work. Or, this is the Tinker Workshop, man. I got my spanner and I'm ready to go. $9.85. That's like 1,000 RPMs.
Wow.
Look at how bright the light is. Ever seen it that bright?
No.
It's not even flashing.
It's a lot brighter on the camera.
Yeah.
I can tell you that.
I hope it's not blinding anybody.
Whoa.
See that spike, ladies and gentlemen? That was at 18 volts.
I never have seen it that bright. You've never seen it that bright.
Did you see that spike?
I saw that. That was a little crazy.
Yeah. No kidding, Peter. I could not imagine being shocked by that, right? That spike.
Can you get the
was
cat out of
amazing.
here?
Yeah. I'll get Tiggs. Hold on.
Alright.
And take him. Tickles.
I mean, the way it just kind of spiked up like that was crazy. How many times has it done that?
Never. I've never had it do that.
Hmm.
Alright, I'm gonna grab some water real fast, right behind
Alright.
you. And some coffee.
Well, guess who's back?
Oh, I didn't close the door.
Slim Shady. It's our little kitten. His name is Tiggs. He's a few months old. But yeah, Slim Shady is back.
Alright. So, that was awesome. I mean,
Yeah.
that last round right there, we got...
Can I give it a
pretty much-
spin?
Yeah, go ahead. Pretty much 1,000 RPMs. Whew.
Let's see. It's a little different from the last time that I have been on a live.
Yeah?
Mhm.
Which one was on when you were here doing live?
I think it was like the black one with like the magnets in it, and then there was like a ton of coils around it.
Okay. Yeah, it wasn't too long ago.
Yeah.
Oh, Tiggs. Tiggs!
Shush.
No, that's too high.
All right. We got a new sub, and they also subbed to Peter.
Nice, Pete. Heck yeah. Aimless Mouse, you the man. Uh-oh. My daughter warns me about saying stuff like that.
Mm.
I really appreciate that.
I'll let it slide this time.
Thank you. Thank you. Man.
All right, slide like an electron. Indeed. I'm 55. It's all good, lol.
All right.
Wonderful. On the path of least resistance.
Sweet, sweet. All right, so, well, I don't have another, yeah, I do, but it's like, gonna take me a little bit of time to get it the way we need it.
Currently just spinning it because there's no other form of entertainment to do right now.
What is it?
It could be Chris or Caleb, either.
Right, I'm trying to figure out which one it is. Probably. Oh.
Yeah.
I got an idea. It might be a little tricky to do. But we're gonna move some aluminum.
Here's another spin.
Alright, now stop it real quick. Alright, now I'm gonna turn it on to flag range. Go ahead and spin it.
There we go.
Alright, we did something like this earlier in the season here.
Add a second layer on top of this one, at least a fourth the size for the pickup, and use the side of the magnet where the north becomes south, with the south side facing the direction of the spin.
Yeah, does that require that I build a new rotor? Sounds like I need a new rotor for that. Maybe. Will it fit in this rotor? I think it will, actually. Yeah, we could probably do that, something like that.
What's this contraption you got here?
This right here?
Yeah.
Come here and show the people what's underneath the table right here.
Hold on. Yeah. Under the table?
Yep. Right there, behind the battery.
Oh.
Black thing that's hooked up to what you were looking at. Yep, right there. That's a DC motor for a lathe. It's 3,500 RPMs. I gotta get a shaft.
I've built hydrogen generator and like learning electronics and chemistry. Just amateur stuff, but fun.
Heck yeah, lots of fun. I'm gonna try and move an aluminum disc.
I had one on my Jeep and Honda. Both gave me 30% better gas mileage.
Sweet. Always
No, I'm gonna
better
leave it at
gas
that.
mileage.
Back to the rotor. Oh, look at that.
Alright, show them what I'm doing real quick. Lining all these bearings up on this shaft like so. And then I'm going to shove them in here in this little sleeve like that.
I believe I've seen you do this before.
Yeah. And then I'm just going to plop this on the end here.
Yep, you've done this.
Now we're going to find an opening next to the rotor. And this is all north. Oh, I'm going to need to be like right there.
Oh, let me scoot out the way.
Yeah.
There.
And that's monopolar.
Perfect. Here, let me. Ooh, that's a little too close. There we
I
go.
want to let it go. Kind of. Oh, that's not going to work.
Good enough.
Yeah, using all north currently. Pure eddy currents right there. Well, it would if it was not able to spin. It would slow it very fast. Let's test that out. Yeah, it's kind of like a brake. Heck yeah. And this is just at 5 volts. I'm pretty sure it would spin pretty much in sync all the way up to 18 or whatever.
Eventually they do resonate with each other. Check the speed of the first wheel.
Oh, I can't. Could you grab me that gray thing over there, Paige?
Yep.
Thank you. Yeah, that.
Here we go.
$388, 388,
388.
384, 387, roughly. And I don't think this one's going to give us a reading. And I've heard all different ways of how to get one, and I haven't been able to get one, so I'm not really worried about it.
Take the wheel away and see the RPMs go up.
Oh, on this? For sure. But the whole idea is to spin the second wheel, regardless of whether it's slowing the first one down or not.
I wonder if I put the camera on the TV, if it would like mirror through.
That's interesting.
Like you'd see multiple of the phone.
It does slow the rotor down, yeah. It slows it down real much when I hold it still. And it slows it down less when I let it go.
Like a time tube, but look at the screen and it'll do it.
Alright, now, could you turn that up?
Left or right?
Left. Other way,
Oh.
not bad. Right.
How much do you want it up?
Go to 9 on the orange.
Okay. Oh. Stay at 9. There
That's
we go.
good.
There we go.
Yeah, that's good. Now, it would be going twice as fast. I'm talking about the aluminum rotor here. It would be going twice as fast if, say, there was a north-south arrangement on this rotor. It's north-south, excites the eddy current thing a lot faster.
French.
Hey, hey. Yeah, north-south would definitely make this thing spin even faster. And I might rearrange the magnets like that.
What a fun and educational childhood.
Haha, yeah. See, oh yeah, heck yeah.
Yeah, Paige, you're lucky. Yes, I am. Very lucky.
I feel the same way, Paige. I'm very lucky. Now if we move it in there nice and tight.
Don't let it grind up against each other.
That's moving even faster now. There's a blue piece of tape on this rotor that
Saw that.
you can't see now because it's going so fast.
Now, does that interfere with the speed of it, or is...
Does what interfere with the speed of it?
the tape?
No,
Okay.
absolutely not. Oh man. See, and then you get a burst of inspiration, right? But it comes a little bit too late.
Yeah.
Shoot this.
Pew.
Okay, boom.
Pew pew.
You got.
You said shoot this.
It's a compressed air turbine. You gotta have horsepower worth of air flowing through this thing, but it works pretty good.
Is it like one of those what are they called? Wind turbines?
But these would have made good caps for rotors. And Brandon from Over Unity Research showed me that this is not the best use for these.
It kind of looked like one of his designs, though.
Yeah, because he uses these to put on either end.
Yeah.
And this is a bunch of them that I glued together, so that's naughty me.
What are you stealing from Brandon?
No.
Yeah.
Oh, okay. Wonder what to. Oh. Yeah, I guess we could check this one out real fast.
Alright. I tried spinning it and it doesn't really spin smooth as that. But it'll spin.
I got that one flux rotor that has the big square neodymium magnets in it, and north-south. It's not alternating, but it does. It is pretty powerful, and it spins for great amount of. I could set something up like that. But at the same time, it is not in wedge coil formation. Here, wedge coil formation. Okay, so it's not like this, and so the magnets would be long rectangle magnets. Yeah, I agree, Peter. We need to get some stuff going on.
Is he part of the Discord server?
Yeah, he's on there.
All right.
But yeah, I think if there's any way that I could reclaim those magnets on that rotor, I would make a new rotor and a better one with this inspiration that I'm getting from this.
I probably told this story last stream, but here we go again. There was this kid in my class, and he studied Nikola Tesla, or
Yeah, Nikola?
yeah. And I could have got my chance to do that, but two people can't study the same person. If I had known that I was going to be doing this.
And then we can hook up an SG circuit front to back. I have two batteries here. I have no idea how to hook that up. I mean, obviously the input's easy, but the charge battery, I don't know anything about it. I got one though. Alright, so we can even try and run SG to run this motor. I don't know if it'll work. It's a DC motor underneath there. Alright.
Now I know a few things about Nikola Tesla, like he studied a lot of this stuff and discovered things as well. So that's how it's supposed to spin. You gotta hook everything up and then it starts going rapid.
So this is half of its natural speed.
Sounds like a helicopter.
So this is 6 volts. That's freaking awesome for 6 volts.
And then we got this one going on 9 volts.
Yep, and not even reaching anywhere near the speed. At 6 volts. So I mean,
we got 9 volts and 6 volts, and this one does not compare to that.
so
Crazy.
I'm gonna need to check out what's being said.
You want me to scroll up?
Yeah, scroll up a little bit.
Alright.
Right there. A little bit more. One more. Yep. Okay.
Down.
Yeah. Yeah. You need to, the Tesla turbine needs to be modified for wind because it's designed for, liquid or fluid. And so, yeah, I would change what it's designed to allow that to happen better will allow wind to happen better. Steam might even be better than wind.
Huh.
But I'm
Because steam is a bit more heavy.
yeah, you can put pressure behind it too.
Yeah.
That's the best part.
I know it sounds crazy saying steam is heavy. Well, it is. It's heavier than air. I don't think by much.
I just
'Cause it
stick with my
floats.
2 horsepower shop vac right now. But yeah, I definitely want to explore this. Shoot this, please.
Pew.
And this one's pretty heavy, but hey, what's up, Woody? Woodsy Fox, what's going on?
You remember him? Alright.
Oh yeah, and see, like you can put magnets on the edge right here.
Use the turbine to drive a water hammer.
Okay, what's a water hammer and why would I want to do that? Just curious as to what it is.
I think a water hammer is one of those. I don't know. I'm thinking water wheel. It's not a water wheel.
This can run as a water wheel too. You just air can be shoved in right here,
Yes,
and then water would just fall like right here.
indeed. It makes steam very fast.
All right. Heck yeah. Steam is a good idea because steam, you can build that up and then you can apply pressure with the heat and everything works good with steam.
Where are we gonna get the steam from?
Well, I mean, we're working with electromagnetism right here. We could make a heat coil, and water is basically how you get steam.
Yeah. Like when you're boiling water or even taking a really hot shower.
Yeah, boiling water. That's basically how we get steam. Yeah.
If the water from the shower is steaming, aren't you boiling yourself?
Yeah. I'm not talking about a shower, no.
Okay. A water hammer is for inline pipes to prevent pipes from banging. Am I just now noticing that this is brightening up?
Yeah, I just turned it up.
Oh. How much does it need to get for it to get to the point where it was at
4
before?
volts is what I usually put it at for break.
All right.
All right. Yeah. Okay. Let's. I know we just fired on some neurons right now with the Tesla turbine impression over here. This is not a Tesla turbine, people. Okay, this is something that I built. Show this, please. I'm talking about this.
Okay.
All right.
You made that with a 3D printer.
Yeah, this is not a Tesla turbine, but we can do some stuff. We can use that as like a model or something. Right. So let's not tackle it like it is. I mean, let's explore our own pathways and make our own thing. We can say at the end that it was inspired by Tesla, but Tesla won't have anything to do with this.
What's the goal here?
Go in my hand.
I think he means in general.
The goal, I guess, for this is for it to pump itself somehow with either air or water. And I'm not saying without an input, but definitely where you can tell that it's being recycled and being used to perpetuate its motion, even though it's not perpetual. I don't know how to say it. That it aids in the spinning of this wheel. So we're looking to take the exhaust from the system and reinstitute it into the input.
Well, I've seen enough. Good luck.
Thanks, Dan. Peace out, man. All right, man. All right. For all those people who have a purpose, good luck. All those people that have, like, you know, a definite goal or end, good luck. I would advise that you don't let that get you down. I would advise that you put something out at the deadline, regardless of whether or not it's perfect or not. That's what I suggest.
What's this? Well,
That in the middle is a pulse motor. These are SG circuits right here. Yeah,
When's
you
the
don't
deadline?
need to relay all that crap.
when's the deadline?
For this,
I don't know.
alright, and don't leave without putting it back in its stand, please.
I turned my head and then I just see an entire paragraph written by Peter.
What are you talking about, Peter? The deadline.
Oh. What's it do? Generates power and spins.
Yeah, it generates electricity. I mean, we got the light being lit off the...
Hello from Germany. Hello there.
Hey, what's up? Yeah, I mean, the thing is to have, if you're going to have a purpose, make smart goals and get it done. My purpose yesterday or 2 days ago, maybe a week ago now, was building this so that I would have a shaft that spins that I could hook it to this turbine. That was my goal last week, okay? I'm not trying to, and I don't know why people are so interested in getting to the end when there's so much raw material right here in front of your face.
So, in conclusion, there's no goal. It's just, new goals from time to time, testing different things, experiments, and it's kind of just never ending.
Yeah, that's the whole point. As soon as you make a solid goal, like a plan, and then you fill all the criteria of that plan, and you meet your goal, you have to stop. You're done. You can do something else now, but you're done. And that alone, right there, goes against everything that this stands for.
I remember Dad once told me there's no goal.
No, see, now you're confusing achievement or achieving a goal as being the same thing. I achieve something every day.
Well, yeah,
regardless
you do.
of whether or not anybody out there thinks I do. I know I do.
Achievement feels great, indeed.
So I don't need anybody to pat me on the back. I know that I get stuff done. And if it's screwed up, it's because my teachers are screwed up.
How much of this did you learn in school back when you were in school?
I learned the basic circuitry in 6th grade science.
How?
It's true.
How?
I mean,
what?
we basically decided that the cores elongated were good. Now I'm hearing that they're not. I mean, come on. I got people, and then people coming at me with the chat crap. I mean, I don't want to hear what you heard from AI because I already know what it said.
You look like my science teacher. No offense. You look,
Really, man?
you
I
look like
mean, if you're going to go straight to the AI, and it's okay. It's got lots of good stuff. I got my own account, you know, but I've seen its limitations.
Same.
I've seen its limitations. And that's why it's not live yet, because it's got limitations.
Has anybody heard of the saying, not everything you see on the internet is real? It's not really a saying, it's just, not everything you see on the internet is real.
I'm not, Peter. Yeah, everything you see on the internet is real. I'm not.
AI is all real. It's all fact. I mean, that's what they say about Google, and not everything on Google is real.
It's all fact based on the written word of humanity, which is in many cases miswritten and misinterpreted.
It's not
it is
Google.
Both ChatGPT and Gemini are both from Google.
It's not Google.
They're both Google.
Does AI generate Google answers, or is it all just, a huge group of people?
What are you talking about?
Like, for, if you Google something, does AI generate that answer, or is it a person typing in the answer?
AI generates all of its answers, but it gets its data from us and itself. It's ever growing. It's always growing, but right now I still consider it to be kind of in its infancy.
Elon Musk made ChatGPT, not Google. Elon Musk makes everything. Okay, that was highly exaggerated. Elon Musk does not make everything.
I think Elon Musk bought ChatGPT.
He bought Twitter, so...
He didn't make it, he bought it.
Yeah, he bought it. Twitter.
And I'm pretty sure it was a Google thing.
Or X.
But I'm not 100% positive. It's just my brother's really anal about me using Google instead of Microsoft. And he might have just been complaining about me not using Google. But I'm pretty sure that he's like, because I had to go to Google to use chat, and I'm not sure that's even a thing.
I mean, I've seen, typing it on Google, maybe if you have that set up, you get a ChatGPT answer above what Google has to say.
All I know is that I tried for 3 weeks to get on chat, and it was bogged down so much it wouldn't even let me log in.
Oh.
So to use it, I'm not talking about me having an account. I'm not going to get an account with something that won't let me use it to begin with. So I just use Gemini, and we're good.
Yeah. Elon Musk was the one of the co-founders of OpenAI, but he did not serve as the head primary overseer of the organization. OpenAI was founded in 2015 by Elon Musk.
Okay.
What?
Okay.
We were kind of just...
That's exactly what I'm talking about, man. I mean, who would say that other than somebody who just read it?
In school, we read an article about Elon Musk and SpaceX and all that.
Right. I know. I understand. There's a lot of data out there, and I know that back in 2013, that there was a lot of advancements made And that's pretty much all I know. I know that I tried for 2.5 weeks to get in to ask Chad a question, and I couldn't. So that's F you. That's all I gotta say, man. F you. You gotta get on top of that.
Owner of ChatGPT.
Yeah.
Fix it.
Yeah.
Fix it. Fix it.
I mean, if I can get on there, I might actually get an account, but I couldn't get on, and I still can't get on. So I'll try again after the thing. But like I said, I pay for Gemini now, and Gemini is good. I'm good with Gemini. We have conversations all the time.
Now, what I use AI for is, there's this app called C.AI, Character AI. You could just talk to any anime character from
I
a
sense
show or
like an
anything.
Apple Microsoft argument coming on right now. That's how I feel where this is going. It's like you got an iPhone, I got a Samsung. F it. Right now, man. Just bury it now, or I'm gonna get mad.
I mean, it's all, you can get it on all the, it's all kind of the same. It's all really, in general, the same. I mean, you could do everything that you could do on Apple and Android. It's just the same. Except Android is more advanced. Sorry.
I love my Samsung.
And I'm glad you do, because, well, it's just that. Fast.
Alright, listen, I'm done talking about it. I'm about to shut it down.
What?
Really.
No email required. Indeed. Indeed.
No, you can definitely share what you have with our crowd here. But my shit is made up, so I'm done. You can share it for everybody else. I'm good where I'm at.
Because of what I said, no. Have a good night. I'm just trying to help. It's
Like
okay.
I said, you can share it with everybody else, but I don't need.
It's okay.
Yeah. I don't need that kind of help, buddy.
It's okay. He's, a little stressed out.
Yeah, I definitely don't need the bag being waved in my face kind of help, bro. I can't get on chat. What part of that don't you understand?
He's a little stressed about that. And it wasn't even much of him kind of saying it. I was kind of stepping in. It's nothing to lose sleep over. Don't worry. He's fine.
Yeah, I'm all right. I gotta chill out. It needs to stop so that I can relax.
Let's talk true magnet levitation without stability rod and barring.
Let's do that.
Haven't we talked about this before? Like,
No,
a year ago or something?
About is not having a shaft.
I know.
I think that's pretty awesome.
Haven't you told me about the thing levitating
Yeah.
a few years back, and you said that it wasn't really
Well, a few years back.
not a few years back, but that was highly exaggerated.
Yeah, look, Peter.
Pushing Leo.
Yeah, look, man. I'm sorry about getting grumpy. I wear a shirt like every third stream that says grumpy right on it.
How about you put the shirt in the shower? That's a joke from the last stream that I was in.
No, I'm not worried about you. Like I said, sharing the information with the crowd here. That's good. But
Wasn't that grumpy shirt from Chris?
No.
Oh. Thought I heard from one of you that it was his shirt and you just gave it to you.
I have been trying to get on chat for 3 freaking weeks.
Why do you need chat that badly?
Because apparently it's good.
No.
I mean, he just spent so long explaining why it was good. You know. I agree, man. Chat's the better deal, but they've been screwing me. They've been shafting me.
They just won't let you in.
And I think it's because of how many people are using it right now.
Because it's just that popular.
And that's what I thought. And as soon as I can get it, I'll get it. But I mean,
I've never really been a fan of the whole Elon Musk and ChatGPT and all this dilemma. I just wasn't really too high on it. Didn't like it as much. Because it's getting a little too advanced in my eyes. Not to say that it's bad. We've made with permanent magnets too.
Alright, that sounds like something we can do.
Sounds like a plan. Or a goal. An achievement plan.
I've made something pretty cool with neodymium, not neodymium, but ferrite toroids. Yeah, that is a brushless motor. This one isn't though. But that one is.
It's. I mean, we just got done talking about ChatGPT, and then we got robot right there.
Huh.
Message restricted. Make brush motor.
Aren't they loud?
Brush motors. Retracted, not restricted. Did you put a filter on it?
Oh man. Okay. What to do? I mean,
I don't know.
you can see that those lights are right here.
Oh, those. Kind of lighting up a little bit.
Halogen light bulbs instead of neon lights, but they're working for the same purpose there.
You can't stop progress, indeed.
Oh, I'm getting out of the way, or I'm riding the wave, and when the wave crashes into the shore, I'm gonna get out of the way.
Please don't flash again. Please don't blind me. Please don't blind anybody else on the stream.
All right, hey, robot, you can't just plop a question like that, man. You need to elaborate on what you mean by that.
So what is it doing now?
It's just spinning. That's what motors do.
Generating electricity.
It's doing that as well.
Please, no.
Anyway, you know, that's a soft spot. Me not getting my own way in the proper amount of time is a soft spot for me, and chat is rubbing me the wrong way right now.
I feel like if we turned it up a little more, it would do the sparky thing again.
You want me to do it?
No. You're gonna blind me. I've always been kind of curious. What are those hook things? Like the green strap with the 2 hooks. So I've seen those.
Oh, that is a strap. I think it's just called a strap.
Huh?
For the top of your car. It's like
Oh.
to strap something down.
One coil makes it spin, one coil makes it light up.
Well, actually, it's a combination of both coils together. So having the trigger coil inside the drive coil or inside a drive coil, so having the 20 and the 30 gauge coils work together, one as a trigger and one as a drive, allows for that light to light up. Because I did a series of experiments with external trigger, the light never lit up.
But it has power. But it has a power source that doesn't count as generators. That is unique. But the motor transfers power to the LED.
Yes. There's no need to be harsh, bro.
I don't think he's trying.
I mean, he said just transfers like it's no big deal. I mean, it's actually a pretty big deal. I mean, that the whole point of this circuit right here, which is an SSG circuit.
Okay, I think that's enough dissing on Robot. All right, he's trying. You need more magnets for more rotation speed.
Yeah.
But the power that it transfers is transformed to higher voltage.
All right. So I encourage.
What is this?
People who came in later to go back to the beginning where I did the experiments with all the different inputs.
Can you spin it again?
Yeah.
Alright, what is this? This is a pulse motor that spins and creates electricity.
So we're going to start with 5 volts in. Go ahead, give it a spin.
Wasn't a very good spin, but
That's fine. That'll work.
Not true. The timing is what controls the speed.
Go over here. Show them this.
What?
Oh, all right. This is where the light turns on, around 8 volts.
Not very bright, but
9 volts.
9 volts in it. Ah, power source.
Yeah, I'm not trying to hose anybody. I'm running with a DC power supply that is 25 volts and 20 amps capable. Potential of 480 watts.
Well, that light has its own regulators inside, etc.
You're absolutely right. It's supposed to be mimicking a 1,000-watt metal halide bulb.
Slant the rod or the base. I think it will reduce air resistance.
I'm trying to explain something.
The
1,000-watt metal halide equivalent is a 100-watt LED. It's all whatever you said is true, but that's supposed to be a 1,000-watt bulb. Okay, and it's only a 100-watt bulb, so all that's being accounted for when I do this. The light's dimmable by my knob over here. Mm-hmm. It is.
If you turn up the voltage, it'll...
It's not dimmable otherwise. I mean, you can hook it up to a dimmer circuit. Yeah, I guess you could adjust the brightness of it.
The higher the voltage, the brighter it gets.
Not just by plugging it in, though. You need to have a special knob that'll do that. This is all you get with the lamp that I chose. It's right here.
I thought it was going to turn it brighter, so I was scared for a second. Let's get a top view. When you get closer, it's less brighter, but then when you get farther away, it seems like it's shinier. Hi, try creating an AC
Well, what I'm
motor.
going to do is I'm gonna try and create an axial flux motor that uses AC, no doubt. That's what it's called, an axial flux motor, or a radial flux motor. But I'm going to be using flux, AC flux, and eddy currents, and an aluminum rotor.
Text stories. What's the conversion rate? There's a lot of questions in this stream.
Yeah, it's all right.
What's the average?
Okay, what do you want to know, Yogi Bear? AC to DC efficiency. I don't have a multimeter hooked up to anything right now.
I think maybe to speed it up, try slanting it and then give it a little bit more of power in the top and coming down. How would slanting it make it go faster?
There's nothing going to slant on this build anyway, so I don't know.
I have an idea. Do you like to create robots?
I've never created a robot.
Neither have I. It's okay. Love this stream. Best one I found today. Got my subscription for sure. Wonderful.
Thank you, Yogi. All right, we got to let you go, guys. I think my phone is about to die.
Oh man.
Oh.
This was really fun though.
Heck yeah, thank you, Paige. I really appreciate you coming in and helping me out.
Yeah.
I'll try to, well, I'm going to get my data that I wrote down about the experiments. I'm going to try and type something out and put it up on my site. Thanks, Yogi
Kind
Bear.
of true though. Yeah.
Yeah, we're gonna now if you visit my channel and you go to the about page, my email address is there. If you'd like to join my Discord, please send me a email. I'll get you hooked up. Thanks for watching. Peter, you the man. You put up with a lot for me, and I really appreciate you. I really appreciate you, man. I do.
Oh, there's Noah.
Hi, Noah. And you got a lot of great ideas, man. Hopefully I can join you in chat.
Let's go.
And get some of that. Obviously not. Jesus.
Dang.
Dang. Dang.
Bye, Noah. Bye, Peter. Bye, M.P.H. Jr. I work at NASA. You work at NASA?
Awesome.
That's
robot.
amazing.
That's cool. Bye, Yogi Bear.
Yeah. It is Paige. Hi.
Alright. So I'll charge up my phone. Maybe we'll be back on later tonight.
Thank you. See ya.
That's
A robotics engineer at NASA.
that's awesome, robot. Are you a robot or is it just a name?
Why did I think that at first? Because we were talking about
Because that's
ChatGPT.
just, I mean, it's supposed to be coincident, like, you know, like the awesomest coincidence, but.
I think he's named that because of his job and he
Right,
likes what he
right.
does.
Yeah, me too. Me too. But I'm pretty sure that's not the first time that question has been asked. I'm hoping it's not. Beep boop bop. Beep boop bop boop. Beep boop bop.
Rovers. Rovers.
Nice. Nice, dude. Those are like
Rovers.
the key. Peace. Peace. Those are like the key to the ground exploration of other planets, man.
Mm. Holy cow.
All right, so thank you all very much. And yeah, occasionally I can behave like such a thing, but it's all right, man.
Everyone accepts it.
Yeah.
The rover that went to Mars.
Yeah, that little devil was awesome.
Oh. The Curiosity robot. Have you ever heard of that?
No.
The robot that actually went to Mars? Or the rover?
Oh,
Not the robot, the rover.
I didn't know it was Curiosity.
It was named Curiosity, and then there was one named Opie, short for I think optimistic, something in that range.
All right, yeah, no, I'm sorry. I didn't mean to offend you, robot, if I did.
Probably spent a lot of time on that, or helping work on it.
No, I think that's a great project. All right. Well, hopefully on one of the next streams that I do, here, get this real quick. We're gonna hook up the batteries. All right, thanks, robot. I hate it if I do, man. That's not cool. So we're gonna hook these up, the SLAs.
Robots don't get offended.
All right, so I got two of these bad boys. They're only 9 amp hours, but
Add if you wish. Is he talking about Discord? Oh. Hey, no, I'm gonna sue you. Robots don't sue.
they do. Noah.
Uh-oh. He ain't got no money.
Yeah, you
Uh-oh.
gotta get that robot pro bono returning. The one that doesn't have the upgrade. You know?
He's the one robot that sues. Uh-oh.
You gotta get that.
We were gonna end the stream, but we ended up going an extra, 6 minutes.
I love the lawyer bot, that's right.
Lawyer bot? He's a lawyer bot.
It looks like Beetlejuice.
Robots don't watch YouTube.
I know hackers.
I am a human.
I know, robot.
Uh-oh.
Alright, let's wrap this up for right now.
Alright.
Thank you much, ladies and gentlemen. Peace out. I really appreciate you coming by.
Okay.
And we'll continue with our experimentation. As for the final build, I don't want that to happen for a long time. Because that means I'm done. And that means I don't want to do this anymore.
Don't quit.
I will hopefully complete a motor though. Like, I mean, you could call this one done. Actually.
Uh-oh. Noah, you gotta flee the country and change your name to Bob.
Peace. Alright, let's.
Alright.